Welcome to our class on the t-distribution. The t-distribution is used for samples less than 30. The t-distribution table looks like what we are saying. We have the degrees of freedom, which are numbers 1 to 30. And we have a one-tailed test percentage and the two-tailed test percentage. So we are going to look at a few formulas that accompany the t-distribution. To start with, it's important to know that the t-distribution is used when samples are less than 30. So for a two-tailed alpha over 2, the degree of freedom is usually n minus 1. For two samples, we just add n1 plus n2. Instead of subtracting 1, we subtract 2. And if we're testing, hypothesis testing for a t-test, the formula for a single sample is the same as that of z. Except that here we use a sample standard deviation S. And if we're dealing with two samples, it is x1 minus x2 is the mean 1, mean 2. And this is called the pooled variance, 1 over n1 plus n2. And this is a pooled variance formula. In detail, we'll explain that later. For now, how do we read the t table? So you start with identifying the level of significance. What's our level of significance here? 5%. And you have it 2.5%. And our degree of freedom for one sample is n minus 1. For two samples, it's n1 plus n2 minus what? Minus 2. And the final stage is you read. So far, are we on the same page? Are we together so far? Is everyone on the same page?
Yes. Yes.
So now we are going to, our n is 10. So 10 minus 1 is 9. This is a single test. So here we're going to the table and identify it was what? 10% divided by 2, it is 5%. 10 minus 1. What is 10 minus 1? 10 minus 1 is 9. So we are going to get 1.833. 1.833. Okay. 1.833. Let's try with part B. What is the level of significance? It is 1%. And what do we do to this 1%?
Divide it by 2.
You get what? 0.5%. Then what do we do?
We find our degree of freedom, which is n minus 1, which will give us 9.
N is what?
9.
9 minus 1?
9 minus 1 is 8.
So we read 1%, 0.5 under 8. So So let's go there. So what is the reading?
It's 1.860.
Reading are you getting?
1.86.
1.86.
Oh, 0.5. Oh.
So, what reading are you having? 1 point. So what reading are you having?
I'm getting 3 points.
Remember, 1,
3.5.
0.5 under 8. 1, 0.5 under 8.
3.355.
Yes. 3 point. So 3.355. Okay, so let's try this last part here. The reading for this one here. So it will be what? 2%, then 1%, then the degree of freedom, you add this plus that and subtract 2. So 11 minus 2 is 9. So instead of reading, you go to 9.
Two point eight to one.
So what figure are you getting? What figure are you getting?
2.8 to 1.
0.8 to 1. Do we agree? 2 under 9.
Yes.
Okay, so this is how we read the T. Except that sometimes the tables look weird.
Yes, like the one we used here.
So let me take you to a weird table for the T distribution. So you can send what you have on the tape on the group.
Okay.
The one you use. Sometimes we'll be given a different type of a T table. Now this table looks at only the upper tail probability. So the first step is you find your alpha divided by 2 and the degree of freedom. So if you're given an alpha here of 0.02, you divide it by 2, you get 0.01, which is this part here. And if you're given 2 samples, add them and subtract 2. So this is 6 plus 5 is 11 minus 2, we get a 9. So the reading will be 2.821. Similarly, your alpha here is what? 0.10. You divide it by 2, 0.05. So we're dealing with this part here. Then you add these 2 and subtract 2. 20 minus 2 is 18. So we go down here, our 18 will be on 1.734. Sometimes we may even be given the significance level. And the significance level is 1%. And we have 1 sample or maybe 5. So you convert this into alpha, which is 0.01, and divide it by 2, 0.005. So 0.1 divided by 2, 0.05. So we're looking at this part here. So here you need to be very particular about the decimals because some people get confused. Then this is 1 sample, 5 minus 1, 4. So you go here, under 4, 1, 2, 3, 4. You're going to get 4.604. Now, having learned how to read the T table, the examiner will now ask you to find confidence interval and the hypothesis. So under estimation, now we're able to use that knowledge to calculating confidence interval. Confidence interval for a T is simply the mean plus minus T alpha over 2 n minus 1. Now this is just what we're following. So you don't need to subtract the answer you get minus 1. This is a problem students have. So suppose we have our mean as 10 and our sample as 5 and our standard deviation as 3. And we have our alpha level at 0.2. We are asked to find the confidence interval. So step 1, we substitute what we have. Where there's mean, we put a 10. Our alpha, we know how to read it. Step 1, find the alpha level, which is 0.02. Divide by 2, we get 0.01. Minus 1. 5 minus 1 is 4. So what is the reading here? 0.01 under 4. You go to your table. Check 0.01 under 4. 3.747. 3 point. We get 3 point what? 3.747. So that's 747. That's what you put here. Don't subtract anyone. This is the whole procedure that has been done. And the standard deviation is what? 3. The sample size is 5. So calculate the confidence interval at this point and try to find the confidence interval. If we had 100 here, the n was 16, and the confidence level was 95, and our standard deviation 8. Find the confidence interval. So here we have a 10 plus minus. What final answer do we get here?
Isn't our confidence interval 3.747?
It's for 7 years.
Okay.
2.7.
Our final answer is 15.
The answer is what?
15, our final answer,
Final answer is
plus 10.
15 here.
No, including the 10. Oh,
It's a
Okay, there we have 5.027.
times 3 divided
okay,
by
that is
square root of what?
5.027.
Yes, 5.027.
Yes.
And what is our lower bound?
4.973. 973.
The upper bound?
15.
Okay, so we go to the next one here. What is the confidence interval? In the mean, we're going to have what? 100 plus minus. How do we read this? N alpha here 95% is what?
0.05.
0.05 and divide by 2, 0.025.
0.05
Then our N is
is 15.
15. Now it becomes our reading. So we go to
0.286.
0.025 under what? 15.
15.
What do we get? 2.131. 2.131. So 131. Okay. So here we're going to have 21, 21. Then our standard deviation is what? 8 over square root of 16. So we're going to have 100 plus or minus. This is what? 4. 4 in there is 2. So 2.131 times 2. What we have here? 100 plus or minus 4.262. So what's our lower bound? 104.262. And our upper bound is what?
The lower bound,
Lower bound is what?
95.738.
5.738.
38.
Interesting, right?
Yeah.
Anyone behind so far? One behind before I proceed? So how do we handle a question that has this interval So we're going to put an exam question here. So here we are given chain store intends to estimate average sales per week. A sample of 36 shops in different locations computes mean sales as 50 with standard deviation 24. Find a 95% confidence interval. What are we given? N is what? 36. X bar is what? 50. Standard deviation is what? 24. And the confidence level of 95%. Are we using T or using Z?
Z.
Right?
Z.
Why? Because sample is more than 30. So what is the Z at 95%?
1.6, 1.9.
0.96.
Yeah.
Okay. So confidence interval is equal to what? X plus minus Z standard deviation over square root of n. So here we're going to put on X 50 plus or minus our Z will be 1.96. Standard deviation is 4 over square root of what? N. What is the sample size? 36. Square root of 36. It's easier when the sample size is more than what? 30. 5 marks for that. Sometimes examiners will be funny. They'll just say we have a data set of 2, 4, 6, 8. Asked you to find a 98% confidence interval. Know the confidence interval here is X bar plus minus T and the deviation over square root of n. In this case, we don't have a mean, we don't have standard deviation. We go to our topic 1, let's give the statistics 2, 4, 6, 8. This is one topic most people underrate, but you need to understand it. 2 squared, 4, 16, 6, 64. The sample size n is what? 4. Add this, we are going to get 20. When you add this, we're going to get 220. Our mean, what's the formula for the mean? Summation of x over n. This is 20 over 4. Which is 5. The variance, summation of x squared and summation of x power 2 over n minus 1. This is 20 minus 20 squared over n, which is what? 4. Everything over n minus 1. So our variance at this point becomes 220 minus 100. Because this is 20 times 20. 4 into 20 is 5. 5 times 20 is 100. So 100 minus 220 is 120. 120 divided by 3 is 40. So standard deviation is the square root of 40. What square root of 40. Six point what? 3, 2, 3, 5. This will help us now compute the rest here. Mean is 5. G for the stages. Standard deviation 6.325. N is 4. The stages for reading the T table. Step 1, find the alpha. Alpha, since here is what? 98%. So here we have 0.02. Divide by 2, 0.01. N minus 1, which is at 3. 0.01 at 3. What becomes our reading? 0.01 at 3 becomes our reading. 0.01 at 3, 4.541. 4.541. This is what we have here, 4.541. So far, anyone behind at what has been done? Who's completely lost? Do you understand where the mean is coming from in the standard deviation? Rocky, are we together?
Yes, they are. We are together.
Mumbi, Henry,
Very much together.
yeah, the only lady surviving, the rest are confused. How is it so? We were expecting you to also drop out. Okay. So when you multiply this, you're going to get the standard error, which is what? 6.325 divided by 2 times 4.541, which is 14.36. 19.36. And this is negative what? 9.36. This is our confidence interval. So I'll end here for now. Unless there are any questions, speak now.